a lot of people want to get their hands on PLCs and get involved with PLC, and this is a good way to do it. Even though it's function block programming, it's still programming, and I promise you this method here is better than trying to utilize something like an Arduino board. Hi, how's it going? I'm Malachi, CEO, engineer of Elite Automation. Welcome back to the Elite Automation YouTube channel. So last week we did a video where we went over the hardware of what I think is the most affordable PLC on the market. And that PLC is PLC-V8C-PT. It's a SAM2. It's the version 2 of the Phoenix Contact PLC. So we get all our Phoenix products through Neff, and we'd like to thank Neff for letting us utilize this product and just overall providing us good support. Let's go ahead and jump into the computer and see what all we have going here. So one thing that we try to do on a lot of our videos here is we try to include all the information, software, and anything that may be needed to do the things that we've done in this video. We try to set up a Google Drive, and the Google Drive link will be down in the descriptions below. So as you can see here, we have user manuals. If you click into the notes here, here is the website if you want to utilize that to be able to review the product on Phoenix's actual website. Let's go back into our drive again. Then we have programming tools. So if you just want to download the software directly from us, you can do that as well. When it comes to downloading the software, one thing to keep in mind is you need to download the driver as well. So that way your USB port can talk to your PLC. So download your driver first, then download your Logic Plus setup software. So your Logic Plus is the software that's utilized to program this PLC. So we've already went through the process of downloading the driver and downloading the Logic Plus setup. If you have any problems with downloading your driver, you may just want to go ahead and run that as an admin. Same thing with your software as well, just run it as an admin. Alright guys, so now that we're in the software, what we're going to do is we're going to go ahead and connect with this device. And in order to connect with this device, so you already have your driver installed, you obviously have your software installed, or you wouldn't be here in the software right now. Let's go ahead and go into our devices here, and then communication settings. So in the communication settings, you should have your USB cable plugged into your PLC and also into your computer. And what you'll see is you'll get available devices pop up here. So whenever you see the available devices on your network or whatever, you can click onto it and essentially hit OK, and you're now connected with your device. It's literally that simple. Just make sure you have your driver, and also make sure that you're using the proper programming cable, because some USB cables are just power cables and they're not data cables. So just keep that in mind, because if you're using that wrong cable, it's not going to connect. It may even give power and looks like it's connected, but it will not actually be able to communicate or even show up at all. So just keep that in mind. Okay, so let's go ahead and jump into the program that we have here. Let's jump over here into the software and show you guys the project we have currently running. We are currently connected to the PLC. As you can see here, we can switch to programming mode. So we're going to come here and we're going to go ahead and go run on device, because I want to show you guys the program that we have here and then go through the process of setting that up. So we are going to go true. And when we go true, you'll see this logic start to activate. As you can see here, we're firing 4 outputs on a 1-second increment. So in this video here, we're essentially just going through some of the navigation, just putting some things on the screen and just showing you how the workflow feels. So let's go ahead and take it out of this mode here, put it back into just a programming mode. Oh, my bad. I need to go back online with the device one more time. So I have this bit here to be able to, so I can just tell it that I don't want it to run this logic anymore. That way I don't got to hear it clicking, the relay. I don't want to hear the relays clicking in the background the whole time. Switch to programming mode, file. We're going to go ahead and start a new program real quick. Alright, so we went ahead and started a new program. It automatically named this project for us as Project 3. One thing that I want you to notice is we had those outputs down here that are no longer here. They're grayed out. And this is one thing that makes this PLC as valuable as it is. These cards right here, which are essentially just relays, are configurable. So we'll open this up. Notice you can schedule this thing to be a relay input, relay output, a solid state input, solid state output, an analog input, PT-100 input. Honestly, I don't know what that is. Analog output, and an empty terminal. The empty terminal is used if you are going to leave that as a blank. So I'm going to just go ahead and add some of our relay outputs. So this is the particular one that we have. Actually, all of ours are filled with this relay output. But like, let's say, for instance, the rest of them are blanks from this point on. We just put an empty terminal. Now, you do have to put in something in these slots. So if you don't have anything else past that, you need to put in an empty terminal. I would highly suggest that you get the blank terminal blocks for the relays, and you go ahead and fill this PLC up with that. One, it just makes sense for spare's sake. Two, there are some knife terminals on the back end of this PLC that could potentially present a hazard. It is low voltage, so it's not super concerning, but I have to advise that you definitely use the blank terminal blocks. And me personally, for whenever we do applications, I'm going to fill this thing up with something. I'll fill it up with outputs or inputs or something. I'm not going to just let this thing sit blank, because to me, there's always something in the field that changes, that you need an extra input or you need an extra output. So it's always good to have an extra input or output. But on a small application, and you're trying to be very cost effective and as cost effective as possible, maybe it does make sense to just leave them blank. So for our particular application, we have all outputs. So we're going to right click, delete, and then we are going to just fill these all out as outputs. Cool little function that you have here is you can do a Control-C and then go over here and do a Control-V. So I copy and paste these all the way down. Boom, there you go. You have your PLC filled out with all the relay assignments that it has. And now we're ready to go ahead and start programming. So with this particular PLC, is actually a function block type of programming. It's not actually true ladder logic, so just keep that in mind, that what your scan sequences may not operate the same as they do in true ladder logic, but you do have the ability to build true ladder logic type of logic. I'll just drop something in real quick. I'm not going to necessarily do anything with it. You can drop your contact. I'll just do it real quick. I'm going to drop your contact, drop your coil, and then you need to drop a right rail. That's the slow way of doing it. Then there's another way of going about it. You can just drop your left rail, and then you can go up here to the top and say, complete me a rung. And so basically what it'll do is it'll start you a new rung. And from there, then you can make whatever edits you need to. Notice there's a lot of buttons up here. These buttons actually perform quite a bit of functionality. For example, this is a parallel bit. So you can click on that, and then now you're in parallel with your inputs. And you can do the same thing over here with your output side of things. Run them in parallel. And I'm going to go ahead and just delete some of that. So I kind of just wanted to show you a little bit about dropping some bits on here and just showing you how overall it operates, how easily you are able to create bits and rungs, and show you how it's a little bit different than your standard PLC. Also, a super big plus with this PLC software, which I probably should have mentioned in the beginning, but you can run this as a simulation. You don't actually need the physical device. You can download the software. It's free. And from there, you can just start running your own simulated programs, which is great for anybody who is trying to learn PLCs but doesn't necessarily want to buy a PLC. Given, if you were going to buy one of these PLCs to learn on, remember, it's not true ladder logic. It's more of a function block programming. So the scan sequences and things may react a little bit differently in this versus a PLC. But overall, if you ask me, programming is programming. And after you know how to program, you can program on just about anything. It's just a matter of learning the commands and the scan sequence. So we're going to go ahead and create us a left rung. We're going to add 2 contacts into here. And then one of these I know is going to be my flag. So a flag is basically just a virtual bit. It's just a tag name with no real world or input or output. We're going to go F001 for this first one. And this one's going to be our seal break, which up here, you can change this to a seal break type of logic. And if you keep clicking through this, now you can do a positive edge, negative edge, and back to your open contact. So we're going to go to a closed contact. And then this one right here, we're going to name it our flag 0. And the purpose of this bit right here is just going to be so I can activate the logic and deactivate the logic, as you've seen me do in the very beginning of this video. Now we're going to drop in our timers. We're going to go ahead and connect that there. Something that you need to do with this particular program, and you'll figure it out the hard way if you don't figure it out here, is your outputs need to be tied directly to this timer right here. So as you see, I just clicked in there. I created this output right here. Now this is different from if I was to do this and then do a DO8 from here. Notice it's flashing red, and it's not because I utilized it here once. I can change this to a 9. It'll still do the same thing on me. So here we are at a 9. It still doesn't like it. And it doesn't like it because it's not connected. That's actually why it's red. But it don't matter regardless. I could try to connect this here and it won't let me. I'll just show you for example's sake. And connect it. See, it just doesn't like it. It's not blinking anymore, but it don't like it. It has to be directly assigned to this timer. And the reason for that is probably what's going on is they have some programming in the background, and whenever you associate this output with this done bit of this timer, they probably have like some structured text or some other programming language that is performing a function in the background that they're not necessarily showing you here. So it'd be similar to an AOI if you've had experience to those with like Allen Bradley. Now I can click on this and I can do a copy, and then I can click down here and just do a paste, Control V for paste. Or you can come back over here and just drag another timer in. So for me, I'm big on the copy and paste functionality. I can keep pasting. And another thing that's really nice is notice how they keep incrementing up these timers. So they automatically associate a tag name with a timer. So they're automatically generating the tag. And they're generating it in the sequential order, so that way you don't have overlapping timers or tag names. So I'm going to Control V this. About 5 of them's good. And then I'm going to come over here and we're going to basically perform the same function of the DQ 9. So any type of programming that you can do that's repetitive, and you can kind of just, if you know the structure of how you're going to go about programming it, just go ahead and just do all that same process over and over and over again, because it's just going to make your process faster and make your programming faster. Given if you're new to programming, you're not going to be able to do like what I'm doing here, because you won't even know what functionality you want out of your particular PLC programming, or you may not know the structure of what your program is supposed to look like initially. Boom there. So that was that 1, 2, 3, 4, 5. Okay, I'm actually going to change this last one to a flag. So let's go backspace F, and then we want this to be our F001. After we've got all those created, so this last output right here is going to be a virtual output that then resets this, or then turns off this logic here. But we still need to go ahead and tie our done bit to the next timer. Something to keep in mind, there's a couple different methods of how you can go about doing this. One, you can create this branch down like I just did. And if you did this like this first, see how I did that? Whenever I go to add a output to this, it's going to erase that. So after you've learned your software platform, you'll learn little quirky things like that that'll help you speed up your programming process. So we need to go ahead and connect all these. Click on that, grab your dot, drag it down. So this is kind of a repetitive process. Also, I wanted to show you one other method of going about being able to do this. You could essentially probably do a rail and then do a contact, and then have this contact be the like D out, so DQ, I mean DQ 10, and then connect this here. And so essentially this would be more ladder E. Generally this would be the way you'd go about doing your ladder logic and normal ladder logic, versus this method I'm doing here. This is more function blocky. And so this is where you get into some differences in how your programming looks when it comes to function block programming versus ladder logic programming. You can see a lot of different structures within the two different languages. And to be honest, when it comes to function block programming, I've not done a whole heck of a lot of function block programming other than on safety devices. So when it comes to like standard logic, I'm not exactly positive on how the scan sequence works with firing this and then firing a input from that output versus doing like we did on these other timer instructions. So just keep that in mind. Like this type of programming method versus this one here can potentially have effects in your programming depending on the programming language you're using. And that's something to keep in mind because something that may work on one platform may not work on another platform. So I'm going to go ahead and just make this universal like I did with everything else. And I'm going to drag this one down. And maybe we'll test that one out and just see how it acts here in a second. But here we go. We have our bit. What else we need? Okay, so now we need to reset each one of these timers because they're a retentive style timer. And so for this reset, what we're going to utilize is we're going to utilize the bit of the last output, which is our flag right here. So FO1 right there. And so we're going to use that all the way down. FO1. And then here in 1 second, I'll show you something that we did and the reason why we went about doing it the way we did it. So notice I'm using a flag for all of these. The reason why we used a flag on this last timer is because if you just utilize this last bit right here, this output would not stay on for 1 second. So what we're doing is we're allowing this output to turn on, and then we're saying, hey, stay on for 1 more second before you reset. So that's the reason why we have a flag as our last output or bit. Another thing I'd like to point out, we're able to use the same reset bit as we do our output bit in this particular programming language. And we kind of did this as an example to show you that depending on your programming language, you're able to get away with certain things. Like say, for instance, like Allen Bradley, I'm almost certain you can't get away with this. Like this will definitely cause you an issue where essentially what will happen is your timer will reset before your output actually fires. And so what will happen is this will reset. So then all the other places within your logic where you have that output being used, it won't actually ever fire that output. This will always reset before it allows it to fire through the rest of your logic. So that's something to keep in mind, and something that could be considered bad programming practices, or if you know your programming well enough, you can learn how to take the tool and manipulate it to do the things that you want it to do. Because, for example, this, if it works fine, it works fine. Like that's one thing to think about in logic. Like there's definitely some good practices, but on the other side of things, logic that works is logic that works, and that's what really matters, is being able to get a deployable system and be able to get something that has the functionality you want without any bugs. That's where you can run into issues and where some people can argue that doing a certain programming practice is better because, say for instance, something like this could implement a bug that you don't see initially. You may not see it till further down the road, or it may be one of those things where it's a bug that is extremely hard to troubleshoot because it just doesn't really present itself well. It happens so quick that it's happening within milliseconds. So until you start like doing data trackers on certain bits, you won't ever actually find out where the issue is coming from. Now that we have this logic written, I think what we're going to go ahead and do is download to our controller. So run on device, and then it's going to make sure everything's okay. If this thing asks for a password, it should be in the documentation, but I believe the password is admin, all lowercase. So here we go. We are live with the processor now. I'm going to right click on here and go true. Oh, we have an issue with our logic. Okay, turn that false. I forgot one step in this process right here. So we need to come back into our programming, and then we need to do our presets. So I'm just going to do all these presets as a 1 second. So this will be the amount of time that we want to increment these timers and how long we want to keep a light on before the next light comes on. So if you wanted this to be 2 seconds, you'd put 2 seconds here. If you wanted 3 seconds, you put 3 seconds there. If you want it to be like half a second, then you'd put the millisecond area right here. Or the point seconds is what I should say. Because I think it is still standard measurement. Okay, so now we're going to go ahead and run this on the device again. Download it. Go ahead and make this true. All right. So I'm going to go ahead and go offline, and then we'll see about changing our method here to being the, so that automatically did that. So we're going to put a input over here. We need a rail. Put a rail right here, and then we'll connect that, and then we're going to use this to be the output of the previous timer. So DQ11, and we'll go ahead and just download this and see how it acts. So we'll download this to the controller. And so these are really good practices, and like if you want to see like how a scan sequence works, don't spend a ton of time researching the scan sequence of something. Like, just test things. Just plug this in and just see how it works. If you just pay attention to how the PLC code is executing, then it will show the way the scan sequence is actually operating. You just have to be methodical and thinking about like how things are executing and what's executing before another thing. And you may have to play around putting timers with one-shots on stuff to be able to make sure that it's executing the way that you think it is. Because I've ran through times in programming code where maybe I'll put a timer on something, and you'll notice that that piece of logic is not actually firing one time, but it's actually firing like 6 times. But on your graphical interface, it's only showing one time firing. So, you know, something like an add function or a timer could be very good for doing a troubleshooting. So it looks like it performs the exact same way. We'll go ahead and switch back to programming. Go ahead and delete this right here. Let's go ahead and add in one more. We'll do the output of the previous timer again. And just see if any of our functionality changes. Run on device. Okay. Come back up here, gotta make it go true again. So it looks like it has no impact on the scan sequence. That's just something to notate, something to keep in mind, that you're able to go about this route. So if you wanted to program this with this type of structure right here, which is more ladder logic-y, versus this method right here, which is more function blocky. And, you know, a method like this might be good for, like, if you're doing a particular function and you want to keep that function kind of encapsulated and kind of demonstrate that, hey, all this programming logic goes together. Whereas this right here can be a lot harder to detect that, like, oh, this is all part of the same sequence. Yeah, you can track it and go, oh, okay, that one fires that one fires that one, and kind of just keep going down the line of that the one previous fires the next one, and then you'll see the programming structure fairly quick. But this right here has a much stronger signification that it is all connected to one particular sequence. So I hope this video was useful for you guys. Hopefully you learned something. Let me know if you have any questions. Maybe we'll dive deeper into this PLC software. I don't know exactly what you guys want to know about it. And if you want us to implement a small system for you guys, feel free to reach out. Our contact information will be at the end of this video. You know, we generally focus on robotic cells. It's kind of what we specialize in, and like AMR technologies. But we do everything that's related to industrial automation or food processing, things along those lines. And we have another video out as well that kind of goes deeper into what all we do. So we'll put that down in the description below, so that way if you want to check out that video and kind of see what we do, feel free to reach out or put something in the comments below if you do have any more questions on this particular PLC or anything in general. If there's any other video ideas that you have, anything you'd like to learn, maybe we can get our hands on that product. Maybe we can dive deeper into this. This is kind of just a general, just showing you what does the software look like without you having to really download the software, and just kind of see the user interface of it. But take advantage of the fact that it's free software with simulation. A lot of people want to get their hands on PLCs and get involved with PLC, and this is a good way to do it. Even though it's function block programming, it's still programming, and I promise you this method here is better than trying to utilize something like an Arduino board. So thank you for sticking around till the end, and I'll catch y'all in the next one.